Hi everybody, Miss Millender here. Today we're going to go through a quick series of notes on pressure and gas laws. So here we go. You'll probably need a page or half a page probably in your notebook for this flowchart, so keep that in mind as you're taking notes. All right, so we're talking about pressure here. So what causes pressure? If you think back and we talked about the phases of matter when we talked about gases and them colliding with each other. And so basically air pressure is caused by the number of and or the force of the collisions that the gas particles are having with each other and with the container they're in, or with something that's inside the container that they're in. So they're smashing into everything, and it's those collisions that cause pressure. Okay, so if it's the collisions that cause pressure, then what is it that can change the number of collisions? We have three options. The first one is the speed of the particles. So if particles are going to go faster, they're going to hit more often, and they're going to hit with more force when they hit either something in the container, like we'll call you'll be something in the container of the atmosphere. So the speed of the particles are going to change, and so that change is going to be registered on you as a change in pressure. The speed of the particles, when the speed changes, how can you measure that? What measurement can you take that will tell you that the speed of the particles have either increased or decreased? Temperature, yay, exactly. And so temperature is the average speed of the particles. It says kinetic energy here, which is fine, but we didn't really use that term a lot yet anyway. So the speed of the particles measured by temperature can change the force of collisions, which changes the pressure. We also have the number of particles. If the number of particles increase, then there's going to be more collisions, then there's going to be more pressure. So if I add particles, or I add matter, or I remove matter, what am I actually changing? The mass. Okay, so more mass, more particles, fewer particles, less mass. All right, and we can also change the space available. If you take 1,000 particles in a tiny space, then they're going to be colliding a lot. If you then take that same number of particles and put it in an enormous space, they're not going to collide as much because there's more space for them to move around. And so what is it that's defined as the space that something takes up? And that would be volume. Good. Now, what do mass and volume, if you take those together, what other property can you calculate? We did this early in the year. Density, right? So changing the mass of the volume is going to change the density, which is going to change the number of collisions, which is going to change the pressure. So just for a second, I want to talk about the units, just to reinforce those, because we will be doing some calculating a little later. So temperature, what units do you think we're going to use for pressure calculations? So what units do you think we're going to use? Degrees Celsius or Kelvin, correct? However, when we do our calculations, specifically, we're going to be using Kelvin exclusively, but we'll get into that a little bit later. What about mass? What are the mass units that you're familiar with? Grams or kilograms, indeed. And what about volume? Milliliters or liters. Fabulous. Now I'd like to introduce a couple new units, or we haven't talked about them, although you may be familiar with them. Let's go back up to the very top and look at pressure. What are the pressure units that we're going to be using? Well, they're called mmHg, or atmospheres. Now, mmHg, mm is a length unit. What's mm? Millimeters. Hg is an element that you find on the periodic table. Anybody know what that is? Hg is mercury. So mmHg is the height in millimeters of a column of mercury. And if you remember, Dr. Julius Sumner Miller talked about those in his video. Or the other one is atmospheres, which under sort of normal conditions, we live in an environment of approximately 1 atmosphere, but that can increase or decrease depending on what's going on. So pressures caused by collisions. Collisions can be changed by any number of things, and just be familiar with the units we're going to use. So let's move on, and we'll do one last slide. All right, so as you may remember, the pressure only has the ability to push. Now, generally speaking, you're going to look at pressure, compare pressure in two different areas, separated by something. But the only thing that can happen is it can push. So you can't see air pushing, but you can see the effects of the push of the air, such as when trees blow in the wind. Well, the wind is pushing the trees in a certain direction, so you see the trees bend, although you don't see the air itself. So suction, there's no force called suction, but what we think of as suction is simply an area of higher pressure pushing on an area of lower pressure. So when you drink through a straw, for example, the pressure inside your mouth becomes less than the pressure on the liquid that you're drinking. And so the outside pressure is higher than the pressure inside your mouth. So in fact, the orange juice, whatever it is pushed up into the straw. I know it sounds weird, but there it is. So pressure cannot pull. No pulling. So think back on Dr. Julius Sumner Miller's description of the suction cups. Although I understand what we think of as suction, it's not something inside the suction cups pulling them together. The higher pressure on the outside is what's pushing them together. Okay, so that's it. Bring any questions to class, and we'll see you later.